Hello everyone, this is my video and this is regarding the mesh analysis. Mesh analysis is very important, and if you understand mesh analysis properly, it can help you in solving different theorems which you will be encountering later on in the tutorials. So mesh analysis is a basic of any DC network. Okay, now in the next part we'll just see what is the difference between a loop and a mesh. Okay, basically I've written a definition here. It is a path that starts and finishes at the same point. It means that it starts from point A and it should end at point A. Over here there is a simple example which is given. Loop A, B, C, D, F, E and A, our loop, because it starts from point A and ends up at a point A. The other example over here is loop A, B, G, F, E and A are another loop. Once again it's the same reason, and so on. Now what is the difference between a mesh and a loop? A mesh is very similar to a loop, but it cannot be further subdivided. A loop, as you have seen, A, B, C, H, D, F, E, A are further subdivided into other sections, like over here this one, then followed by this is another loop, this is another loop. But a mesh cannot be subdivided into any other format. Okay, so a simple example would just clear your difficulty in it. Over here A, B, G, E, F, E and A are a mesh, and so on. So this part cannot be further subdivided, so this is called a mesh. This is quite important and it will definitely help you further. Let's go to the third slide over here. Okay, so these are the steps which I have jotted down for solving mesh analysis. Firstly, the most important step is identifying the mesh. Whenever a circuit is given, like in the previous slide, there was a circuit, DC circuit. Over there you have to identify a mesh, then assign a direction, which I'll be showing you. In the direction is nothing but a direction for the current. The current will be unknown. For each mesh you identify, there will be separate unknown current assigned to it, and then assign the polarities to the DC network, if any, over there. Then apply KVL, and then this last step is solving simultaneous equation. Okay, depending on the number of mesh, you will get different simultaneous equation which you have to solve using your calculator, scientific calculator. Okay, let's move on. Okay, here I've brought in a very simple example. Hope it's quite clear to you. And over here I'll just explain. The KVL in mesh 1, I've considered this part, this region, this complete region of mesh 1. Okay, so we are just going to apply KVL in mesh 1, and now this is mesh analysis. You must have seen a lot of examples of mesh analysis, but this is a completely different example to any other example. Okay, or a completely different technique rather of solving mesh analysis, which I have found it quite simple and which I'm going to show you right now. Just look at it carefully. Just go on to type I1. Okay, just give a space, type I2, give a space, type I3, equal to, and whatever the voltage is there. Over here we have 10 volt, so just write 10 volt, and the polarity of this 10 volt will be positive, because over here we have chosen the direction of current over here, so it is going out to the positive. So that is the reason why it is going to be 10 volts. Okay, I hope it's clear. Now let's assign the values to I1. What can be the values to I1? Now since we are in mesh 1 and we are going in mesh 1 basically, so what we have to do, whatever the resistors come in mesh 1, 1 ohm, 3 ohm, 6 ohm, just add it, which is 6, 9, 10. So you get 10 I1. Okay, sorry for that, 10 I1. Okay, and over here the sign would be positive. Okay, the next one would be, okay, so this is 10 I1, and now you have to assign a value to I2. And what is going to be the value to I2? Just check out the resistor which is common between I1 and I2. which is the resistor which is common between I1 and I2, and it is this one 3 ohm resistor which is common to I1 and I2. So just want to write 3, okay, 3 I2. And now what is going to be the sign over here? The sign will be only negative. For all the other values the sign will be negative. Just write negative because you are in mesh 1, so just the current I1 would be positive and all the other currents would be negative. Okay, now similarly we'll try and find out for this one what would be the value for I3. Now just check what is common between I1 and I3. The resistor which is common between I1 and I3, it is 6 ohm resistor which is common, so just write 6 over there. Okay, so this is your equation number 1. Okay, now similarly we'll be applying KVL to mesh 2. Now mesh 2 is this one. I have already identified it. I don't think we should have any other problem with it in identifying it. So over here, just continue the process. Write I1 first, followed by I2, followed by I3, equal to, and what is the voltage over here? The voltage is not over here. It's going to be minus 5 volt. Why so? Because as you can see, the direction of the current is where it is going out. It is a small sign, which is we are considering this as negative. This is the basic of it. So this is going to be minus 5 volt. Okay. Now let's go to I1. The sign for I1 is going to be negative. The sign for I3 is going to be negative. Okay. So and what is going to be the value for I1? The value for I1 is going to be common between I1 and I2. So what it is, which is the resistor which is common between those two? It's 3. Just write 3. Now follow it by I2 and mesh 2 basically, which is I2. So over here the sign would be positive, and what would be the value of the resistor of the current I2 is going to be an addition of all the resistors which you find in mesh. It's 3, 2, 5, which is 7, 10 I2. Okay, now I3, which is again there is nothing over here, which is no resistor is common between I2 and I3, so we just want to put it 0. Okay. And similarly we are going to solve mesh 3. I hope you are getting it now. Just practice it along with me so you can get it. This is a very simple explanation of solving mesh analysis. You just cannot get it any simpler than this and easier than this. Now we are in mesh 3. Again, let's type I1 and the sign would be negative for it. Okay, let's go ahead, type I2. The sign is going to be negative for it once again because we're in mesh 3. Then type plus I3. The sign is going to be positive over here because we're in mesh 3. Type equal to and we are going to have equal to 5 volt. That is because as you can see the direction of current, it is going out. So from out it is going to leave from the positive side. So there's 5 volt and 5 plus 20 because over here there's another voltage which is coming in mesh 3, and again the sign would be positive, so in all it becomes 25. So just add 25. Okay, now it's time to assign the values for I1. What's going to be the common between I1 and I3? It is the 6 ohm resistor. Okay, so just type the 6 ohm. Okay, now in I2, what is common? There's nothing common between I2 and I3, so it is going to be 0. Now as we're in mesh 3, just add all the resistors which are in mesh 3. 6 plus 4, which comes out to be 10 ohm. Okay, negative sign. Okay, so now the step 2 which I had shown in the previous table has been completed. Now just take a calci and go and solve it using the 3 equations. You're going to get 3 values of I1 equal to something, I2 equal to something, and so on. I3 is equal to some part of it. Okay, so these are the 3 things I3. These are the three things solving using mesh. You're going to get three values for I1, I2 and I3. Okay, so just so that you can cross check the answers, I have already solved it, and the values which I'm getting over here is 4.27 amperes for I1. Okay, for I2 it is going to be 0.78, sorry for that, 0.78 gain amperes, and for I3 we're going to get 5.06 amperes. Okay, so I hope it's clear, and that's it for today. Thank you, and please hit the like and the subscribe button if you found this tutorial useful, and please share it with your friends. Okay, thank you.